Good morning. So we are going to work on the Polygon test review. So this is for our Polygon test. Okay, so what we have, our Polygon test review. Parallelograms have two sets of parallel sides. A parallelogram So rhombus is a parallelogram with four equal sides. So those four sides are congruent. They have the same measure. A rectangle has four right angles, so it is a parallelogram. So a parallelogram with four right angles. And a square is a parallelogram. So it has all the properties of parallelogram. So opposite sides are parallel and congruent with four equal sides. So four congruent sides and four right angles. So a square is a rectangle, a rhombus, and a parallelogram. Okay, so how do we do the following? So congruent sides. Okay, so we're going to use the distance formula. So that would be our reason as well. So distance formula. So remember, distance is equal to the square root of the change in x plus the change in y squared. Okay, all over. Okay, all over, or you can also use Pythagorean theorem. And remember, that's another form of the distance formula. Okay, we can also use definition of congruent. Okay, parallel sides. So we were going to use our slope formula. Okay, so remember, you can use slope is equal to rise over run. You can also, everybody remember, graph it out so you know which point is to the left or the right for this. So it's the change in y over the change in x. Okay, so if they have, so sides are parallel if they have the same slope. Okay, it's also by our definition of parallel lines or sides. Okay, for right angles, we also use the slope formula, and we have to show that they're perpendicular. Okay, so remember opposite sign. So opposite, reciprocal, perpendicular. So opposite, reciprocal, perpendicular. So reciprocal, everybody remember, so like if I have 3/5, opposite side, opposite would be negative 5/3. Okay, so perpendicular. Okay, perpendicular lines. So remember, when we multiply those two slopes together, they should equal -1. Okay, and then that means that they also, if they're perpendicular, they are right angles. They form right angles. Okay, so this one, remember right angles? So we're going to, it says prove or disprove if it is a parallelogram. Okay, so we're going to go ahead and graph it. 5, 1, 2, 3. So everybody graph these on Desmos to help you do this. So when in doubt, graph it out. So C is going to be right there, and D is up 1, 2, 3. Okay, it looks like a parallelogram, but we can't just say it looks like it. We have to prove it. So graph it, everybody. And then, so remember, if the slopes are going down, it's going to be negative. Okay, so we can use rise. So we go down 3 over 1, over 1, down 3. So if we're going down 3, it means it's going to be a negative slope. Okay, so the slope for AB and the slope for DC is going to be negative 3 over 1, which simplifies to negative 3. Okay, and then everybody, if they're horizontal lines, okay, so these are horizontal, the slopes are 0. So the slope of DA and the slope of BC is 0. So they're horizontal. Okay, so we're going to go ahead and put that over here. So the slope of AB is equal to the slope of DC. That's negative 3. Slope of BC is equal to AD, and that's going to be 0. Okay, and that's by our slope formula. So that means that since the slopes are the same, that means the opposite sides are parallel. So AB, side AB is parallel to side DC. AD is parallel to BC by our definition of parallel. So now we're ready to prove that it's a parallelogram. So opposite sides are parallel, so ABCD is a parallelogram. And that's by definition of parallelogram. Okay, so these are actually, so it says, given the following points, we need to prove or disprove that it's a square. Okay, so we're going to prove it. So we're going to graph it. So at 2, 2, negative 2, 1, 0, 1, 2, 2. Okay, so okay, so we need to prove. Okay, so remember, everybody's slope is rise over run. You can also use the points too. So change in y over change in x. It is totally up to you what you like to do. Okay. So graphing it. So for AB, it's going to be up 1 over 2 over 2 up 1. Okay, so those slopes are going to be positive. So I'll put it up here. So the slope of AB, slope of CD is equal to 1/2. Okay, and then for our other slope, you're going to see that this is going to be negative, so it's going down 2 over 1. Again, over 1, down 2. So it means it's going to be a negative slope. So the slope of BC and AD is going to be negative 2 over 1, simplifies to negative 2. Okay, now we got our slopes, so we can put those over here. Okay, so our opposite sides have the same slope. Remember, if opposite sides have the same slope, guess what? It means they're parallel. So AB is parallel to CD. BC, side BC is parallel to AD. Okay, so that's definition of parallel. Okay, so that means that they're parallel. So that means that ABCD is a parallelogram. One of our properties, remember, is opposite sides are parallel for a parallelogram. So the reason is going to be definition of parallelogram. Okay, so what we need to know, so with that, what I know with the slopes, so 1/2, everybody, so 1/2, do over here. So 1/2 times -2 does equal -1. Okay, so that means that they're perpendicular. Okay, so that means that all these are perpendicular. So CD is perpendicular to AD, side AD, AD is perpendicular to AB. Okay, so definition of perpendicular. So remember with the slopes, opposite, reciprocal, perpendicular. So that since they're perpendicular, that means that the angles, so angle ABCD, are right angles. Okay, so those are all right angles. Okay, so that's definition of perpendicular. Of perpendicular lines. Okay. Okay, since we have that, so remember these are all 2 by 1. Okay, so I'm going to use that in our Pythagorean theorem. So I'm going to take the square root of 2 squared plus 1 squared. Okay, so that's going to be 4 plus 1. So that's 5. So the square root of 5 is approximately 2 2/10. So we're using our distance formula. So AB is equal to BC is equal to CD is equal to AD. So that's 2 2/10. So that's our distance formula. Okay, which means that ABCD is a square. All the sides are congruent, and it has 4 right angles, so that is the square. Okay, so for these ones, couple more proofs, everybody, then we're almost done. Okay, 2 more proofs. Okay, so this one we are going to use the given. Okay, so we're going to have our statements and our reasons. Okay, we're going to do our given first. We're going to write that first. And this is what we have to prove. So remember, that's going to be our last statement. Okay. And I'm going to write this first. So PQRS is a parallelogram. Draw a parallelogram. Okay, and that's because it's our given, our gibby. Okay, and I'm going to go ahead and I'm going to graph it. So -2, and of course label it. So everybody, please graph these on Desmos. Let's just visualize what we're doing. This one's 1, 2, 3, down 2. And then this one is 1, 2, 3, down 1 for S. Oh, definitely looks like a parallelogram. Okay, so we need to prove that the opposite sides are congruent. So we're going to use our distance formula. So this is going up 3 over 1. And we're trying to find this. Remember, that's our C value. Okay, so I'm going to substitute it in. So 3 squared plus 1 squared is equal to A squared plus B squared. So sum of the squares. the legs is equal to the square of the hypotenuse. Okay, so 3 squared is going to be 9. 1 squared is 1. So that's the square root of 10, which is approximately 3 2/10. Okay, so that's for these. So PS and QR is 3 2/10. Okay, and then these other ones, remember they're horizontal, so we can just count. So it's 1, 2, 3, 4, 5, 6. Okay, so PQ and SR are equal to 6. Okay, and everybody, that's by our distance formula. That's the reason. Okay, and so that also means, so it says opposite sides are congruent, so now we can prove it. So PS, since they have the same measure, that means that they're congruent, the same length, is congruent to RQR, and PQ is congruent to SR. Okay, and that's by our definition of congruent. Okay, so this one, so statements and our reasons. Okay, so we're given that it's a rhombus. So PQRS is a rhombus. So that is our given. Okay, this is going to be our last statement. I'm going to go ahead and graph it. So 0, 1, 2, 3, 4. 1, 2, 3, 4 for R. And then S is here. Q is over here. Left 2. We connect them. Okay, they tell us that it's a rhombus. Okay, since it is a rhombus, okay, so that means that PR, so do you see this part right here? And QS are diagonals. Okay, so PR and QS are diagonals. Okay, and that's given our definition of diagonals. So they go corner to corner, vertex to vertex. Okay, and what we know, okay, so remember if it's horizontal, okay, so the slope for QS is 0 for horizontal lines. For vertical lines, the slope is undefined. Okay, so that means over here, so the slope of QS is 0, and the slope of PR is undefined. Okay, and that's by our slope formula, and just also what we know about horizontal and vertical lines. Okay, so that means that those slopes are perpendicular. So definition of perpendicular. Okay, so let's keep going on this. Okay, so we're going to go ahead and look at these. So we have -3, 1, so 1, 2, 3, up 1, 2, 3. Okay, and then over 1, 2, 3, 4, up 1, 2, 3. And then 4, down 1, over 1, 2, 3, down 1 for D. Okay, so it says it's given to us that ABCD is a rectangle. So that's our given, everybody. See, that's our given. So A, B, C, D is a rectangle. And that's our given. Okay, and what we know is, so we're still going to work with the diagonals. And for a rectangle, okay, so AC and DB are diagonals. And we know that by our definition of diagonals. Okay, and how we can figure it out. So everybody remember, we can still figure out what the distance is. Okay, so everybody, so if we look at this, so this is going to be 4 by 7. This is also 7 by 4. So we're going to use our distance formula or Pythagorean theorem. So if I have 4 squared plus 7 squared is equal to c squared, take the square root of each side. 4 squared is 16. 7 squared is 49. We add those together, we get the square root of 65, which is approximately 8 1/10. So that means the AC, so those diagonals are congruent. Okay, and that would be by our distance formula. So that also, since they have the same measure, that means that they're congruent. And so now we can prove that the diagonals are congruent. So AC is congruent to BD by our definition of congruent. Okay, it says find the perimeter and area of the following shape. So we're going to do this. So we're going to go ahead and graph it. So 1, 2, 3, up 2, over 2, up 2, over 2, down 1, 2, 3, 4, over 3, down 4 for H. Okay, and so the perimeter is going to be, so I look at the side and it's 1, 2, 3, 4, 5, 6. Okay, and then 1, 2, 3, 4, 5. Okay, and so we know that it's going to be, so perimeter, opposite sides are congruent, so 6 plus 5 is 11. 11 times 2 is 22. Okay, and then we also have to find area. So area, remember, is base times height, because it's all about that base, no trouble. So it's going to be 5 times 6, which is 30. So it's 30 units squared. Everybody remember area, square, yeah. Okay, so this one, so we got here. So we're going to go ahead and graph it. So 1, 2, 3, 4, 5, up 1. 1, 2, 1, 2, 3, which way? Okay, 3, 1, 2, 3. 1, 1, 2, 3, 4, 5. Okay, so we're going to go ahead and do this. Okay, so how we're going to figure it out. So we're going to figure it out. Okay, so I'm going to use Pythagorean theorem again. So this is 2 over 1, 2, 3. Okay, so for this one, so over 3, up 2 for this one. Okay, so we're just going to do 2 squared plus 3 squared. and then we take the square root of both sides. So we're going to get 4 squared plus 9, which is 13. Square root of 13 is approximately 3 6/10. Okay, so this is for IJ and LK. Okay, so they have the same measure. And then we need to find our other one. Okay, so our other side. So this is down 7 over 4 over 4 down 7. Okay, so I'm going to do that one. So this one's going to be 7 squared plus 4 squared. And then we take the square root, everybody. Got to get to the root of the problem. The root of the problem. So 49 plus 16, okay, is 65. Oh, actually, I counted wrong. So 1, 2, 3, 4, 5, 6. Yeah, this is 6. Help if I actually counted. Okay, so sorry guys, this would be 6. So this would be 36. That changes that. So 36 plus 16 is 52. Square root of 52. Approximate is 7 2/10. So our perimeter is going to be 2 times, as opposite sides are congruent, 3 6/10 plus 7 2/10. So we get 21 6/10 units. For our perimeter area, it's going to be base times height. So we're going to have 3 6/10 times 7 2/10. And we get 25 9/10 units squared. Okay, everybody got this?